Hello, everyone, and welcome to the webinar today with Shapeways and Covestro. We are very excited to have you here. We're sorry that we're starting a little late. We had some technical difficulties, but I think we are good to go. Today, we will be talking about high performance designing with PBT, a 3D printed material that I'm not sure that everyone is very familiar with. So Norelli is going to take us on a deep dive of that material. I want to remind you of a few things during the webinar. If you have any questions, please ask them in the chat and we will get to them. If we run out of time, we will follow up afterwards in an email with you. With that, we're going to jump right in and do our first poll question. So if you look over to your right-hand side, you will see the poll section. And how would you describe your level of 3D printing expertise? If you could take a moment to fill it out, that way we can get a sense of who is here and what type of questions that we might get from you.
With this, I always assume it's going to be a lot of beginner, but based on all the webinars we've done, you never know.
So, I know you might need to change that answer, Steve.
I know. My generic answer of just assuming 50% are beginner is not going to work every time.
It's true. You might actually be right this time, though.
Every now and then, like what's it? Like a broken clock twice a day.
Exactly. Okay, so it looks like we have a pretty good mix of beginner and advanced and a few intermediate that are in between. So with that, Steve, I'm going to turn it over to you so that you can talk a little about Shapeways and why we're here, and then introduce the speakers.
Sure. So most of you probably who are on this webinar are familiar with Shapeways, but I don't know if everybody's like familiar with just what Shapeways has done and really who Shapeways is today. So with over 1 million customers, over 20 million 3D printed parts, I mean, we're doing 6,000 to 8,000 parts a day. Massive global, company. So we got over 175 employees, and we're shipping all around the world. So over 168 countries. And I think what really defines us as one of the top, essentially, additive manufacturing digital bureaus out there is really an on-time delivery. I mean, so we're doing this massive scale and we're getting it to you on time and doing it well. And one thing that we're really, really proud of is we've actually been able to partner with some of the biggest material companies in the world. One specifically used to be a DSM, but now known as Covestro. They're here today and they're really going to talk to us about some of the most amazing materials and things that you actually can produce today with Shapeways. So with that, I'll pass it over to Norelli.
Thanks, Steve. Thank you, everybody, for joining. Thank you for taking the time to join us today to listen to us about specifically, we wanted to give you an example of our material PBT and our collaboration with Shapeways. I'm Nirali Surti. I'm the Global Product Manager at what is now Covestro Additive Manufacturing. I'm responsible for the portfolio of thermoplastics for additive manufacturing, which includes filaments, direct pellets for that direct pellet printing, and powders for powder bed fusion processes. And I will be mostly talking today about our powder bed fusion portfolio and specifically on PBT.
And if you don't know me, I'm Steve Wirt, Director of Customer Success.
And I did not introduce myself at the beginning. I am Rhonda Geet, Director of Marketing Communications for Shapeways. And our next poll question is, what industry do you use 3D printing for? That poll question is now available. And
again,
yes.
Oh, I was going to just say other. I feel like it's always going to be the biggest one here because there's just so many things you can do with additive manufacturing. You know, there's endless possibilities.
There is, and I'm interested to see what people put in the chat for other industries. Wind instrument parts. Oh, I haven't heard that one before. I like that one.
That was cool.
Microfluidics, always my favorite. A big shout out to
what, microfluid dynamics?
Yes.
Is that what somebody said?
Yes, a big shout out to my former colleagues there. Home decor, prototyping for audio products, educational
That's
materials.
cool.
There are some really cool people on here today. I like that. So with that, I'm going to turn it over to Nirali to jump right into our presentation.
Sure. Thanks, Rhonda. Okay. As Steve mentioned in the introduction, so DSM Additive Manufacturing is now Covestro. For those of you who may not know, Covestro is a large material powerhouse. Basically, it was spun out of Bayer a few years ago. They are the inventors of TPU, essentially. And they recently did a large acquisition of part of DSM's materials business, and the additive manufacturing business of DSM was part of that acquisition. So the deal closed formally in April of 2021, and we are actually in the process of integrating with our new company, which is Covestro. So, and we're quite excited about that. And so it's important to know that you might see both DSM and Covestro at times in the document, and that's why that is right now. I mentioned that we are quite excited about joining Covestro, and this is kind of saying why that is. I wanted to tell you a little bit about the history of DSM and where the parallel paths are meeting between DSM and Covestro, and what we could jointly do together now. So many of you might know DSM has been in the business of 3D printing for 30 years now with our street lithography portfolio. We started that with an acquisition of the Somos portfolio from DuPont in 1999. In 2010, DSM took on a project to gather together all the activities that were happening on 3D printing within the company and see if they could make one business out of that. Funnily enough, it was in 2010 that Covestro actually started developing TPU powders for 3D printing. Coming back to DSM, in 2016, we established our first foray into thermoplastics for 3D printing with a partnership with Nixeo, which was on mainly on FFF filaments and establishment of commercial activities in that space. And then in 2017, 2018, DSM Additive Manufacturing as a business was formed, where a vision and mission was laid out to focus on bringing additive to real manufacturing processes, to transition from prototyping to manufacturing, to increase the share of the pie for additive manufacturing. And in view of that, we did a lot of partnerships because we realized that we cannot do it all alone, especially for additive. There are a lot of components at play. So we signed about 30 partnerships. We worked with our DSM mother company on venturing investments. We closed on some 5 venture investments at the time. And in 2020, so last year, we actually acquired the 3D printing business of Clariant. In September of 2020, there was the announcement that Covestro had done the acquisition, and DSM-AM was part of that acquisition. At Covestro's side, the journey was that they started with the development of the TPU powder. In 2012, they started working on SLA and DLP kind of polymers, pre-polymers, and so on. They formed a additive manufacturing business in 2016. And again, they kind of were on a similar trajectory as we were, which was, partnerships and working together with collaborators in the field. And so they signed various partnerships with Polymaker and Gabion and so on. And in 2019, they had their first commercial success. Like I said, we are very excited. As we are becoming one, that's kind of our theme right now for 2021, as we integrate a pretty significant number of people actually integrate into this organization, where we see a lot of similarities, but also a lot of complementary capabilities that both companies bring together. So market access to major industry segments, a stronger combined team across different regions. We are a global company based out of the Netherlands, Germany, China, and the United States. And a really broad combined IP footprint as well as far as materials is concerned. So yeah, lots of things to come, lots of excitements to come in the future.
Now,
Sure.
Nirali, does DSM now not do anything with additive manufacturing and is a separate company? Is that kind of what happened when the Covestro and the DSM additive side?
Yes.
Combined?
So indeed, DSM is no longer active in the additive manufacturing business as it was designed in 2017, 2018. So that's not there anymore. That entire business has been bought over by Covestro.
I see. Okay.
I mentioned this earlier as well, that when we started out when we made a complete business with a focus on polymer additive manufacturing, one of the vision and mission that we embarked on was that we need to come up with a complete solution for customers. That additive manufacturing is difficult enough, and that there are too many choices, and how do we work together? So the standard sort of materials company model that is normally at play, where we supply the material and the rest supply the rest, is a bit difficult. So we developed this approach, which is ecosystems, not walled gardens. So we work together with partners to transition from prototyping to manufacturing. And of course, that doesn't mean that we do it all. We work with partners like Shapeways and so on. So we focus, of course, on sustainable functional materials, tailored solutions, and so on. And we work together with our partners to come up with solutions around high volume digital manufacturing, with economics that work, with design for additive, and so on and so forth. And that's what we are trying to do with Shapeways, right? So we are working together with Shapeways, where we bring the material solutions, and Shapeways has expertise in parts, of course, the finished parts, which Steve mentioned, but also in how do you develop cost models which will make it beneficial for end use manufacturing in the end. Rhonda, I think
our next and final poll question. So before we get into the actual answers of what applications PBT could be used for, I'm interested in seeing what the audience thinks. And of course, there is another other. So if you have ideas, please put them in the chat.
Well, the other question too is, how many people know what PBT is?
Well, I think the first two answers that came in said quite a bit.
Maybe. So we have a lot of different answers here. No one's really jumping out. For all the others, please put them in the chat. We have decorative. Any others that have answered? Health, scaling models. First time hearing about PBT.
Good.
So yeah, I think we have a good collection of possibilities. So Nirali, with that, why don't you jump in and tell us about PBT and the applications?
Yes. So, well, PBT, just for everybody, for everybody to know, is a chemical. It's a plastic. It's called it's polybutylene terephthalate, if that's of interest at all. But it's basically a thermoplastics. It is used very widely in industrial manufacturing, actually. Let me tell you a little bit about the material itself, so then maybe that will clarify what we are talking about. So, like I said, PBT is a thermoplastic. It is one of the very well-known industrial materials in manufacturing and use applications. It's actually one of the biggest applications for PBT in industrial or in traditional manufacturing is in automotive and electronics. So either automotive electronics or industrial electronics. That's where PBT finds most use. The reason we went ahead with introducing PBT as our first powder material to the market was because we saw a few trends coming in, which is what I want to touch upon in this webinar as well. Which is, the electrification of the powertrain, the fact that there are more robust materials which were needed for certain end-use applications, and that's why we introduced this material. There was also a need for materials for functional prototyping, where end users wanted to sort of see that, okay, can we make a part out of a material that we would eventually use for mass manufacturing in the end? And PBT was a perfect segue into that. We also spend a lot of time, effort, and resources to make this material really well processable. So we have a material with a really wide sinter window, which makes it really well processable. You do need a high temperature machine to process the material. So because the material needs to be processed at about 220 degrees centigrade. And we also worked very hard to make sure that the material could be reused a lot more. So we're talking about between 60 to 70% of the material being reused. I will show some data on that in a minute. And lastly, we always work on either sustainability from the feedstock perspective or from a recyclability perspective. So we actually did some studies. At the moment, they are in the lab, of course, a lab scale study to actually bring the material back to the powder bed process, so that that eventually, when you reach a certain scale, that we would be able to implement this in an easy way. So that's what we've been working on as far as PBT is concerned. Look at the powder performance itself. It was important to us that we actually work with another partner. So in this case, it was Jabil. We worked with Jabil, who developed this study for us. So they did this at their end on a machine in their facility. So it was done on a Farsoon HT403P machine. They did the data that you see here is based on 5 consecutive builds, but they in total did 11 consecutive builds without any build failure. And what you see is that you get very stable mechanics with 70% of the powder which is reused and 30% that is virgin. So when it says 30% refresh rate, it's 30% new powder and 70% reused powder. And that's what you see here with the third-party evaluation. The other thing that the other piece of data that is interesting from a processability and a stability point of view is that the material has a fairly stable process window. You don't see changes in crystallization behavior and so on, a very stable viscosity. I think that's something that we heard quite a bit, that, after a certain point in time, incumbent materials tend to become, they become quite viscous, so you can't process it anymore after a certain point in time. So this material does not do that. No post condensation and so on. And then you see that the mechanical properties, so we reached above 3000 MPAs in XY direction for tensile modulus, and just below 3000 in the Z direction. The tensile strength for XY was 49 MPa, and in Z direction was close to 35. And the elongation at break was about 2.5% in XY and 1.6% in Z. We know that the elongation at break is low for this material. It is by chemistry lower than, say, the polyamide 12 that most people will be familiar with here from a polymer chemistry point of view. But we know that this is low and that we are still working on that as well. So that I will touch upon when I talk about the future stuff that we're trying to do with this material.
Okay, Nirali, real quick, couple things just to kind of clarify. So when you're talking about like tensile strength and you're talking about modulus, that's actually like if you're bending or trying to put force, like a megaparsel, right, on an actual item. That's what you're measuring, correct?
Yes. So how stiff is the material in the end? The tensile modulus will basically tell you how much force can that material actually take in the end. So that's what we're talking about.
I see. So it was essentially kind of the overall structure of the parts. You're trying to get a really good, strong part. That's kind of what you're going to do to measure it. Now, when you're talking about elongation of break, are you talking about like just stretching it out and see how long it's going to do until it breaks? What do you mean by elongation of break?
Well, elongation of break, I mean, in very simple terms, would be the brittleness of the material. So basically, you take a part and then you try to break it.
I see.
So
okay.
how the higher the value, so if you have very flexible materials, right, like a TPE or something like that, or a rubber, for example, then you will be, it will be very difficult to break. It will just keep on bending like that. Whereas, you can take any sort of crystalline polymer, and what you will see is that it will break at a certain point in time, and that's what you will measure in the end, and that's the percentage that you get over there.
Okay, so kind of TPU, like what Covestro is like kind of known for. They're
Correct.
really good at the elongation of break, right? So they're
Yes,
gonna
they
have a real
can be
flexible
really
thing.
flexible. Exactly. So, but then you
Yeah,
will use that for flexible applications. Whereas,
yeah,
because if you have to make, which I will talk about in a minute about the applications, I mean, there you don't want that level of flexibility either, because you want the part to be fairly stiff actually, to make
yeah.
sure that it will, sustain all the things that the part is going to go through in its lifetime.
I see. So PBT, end of the day, very structurally sound part,
Exactly.
and that's what you're gonna do PBT for. Okay.
Yeah. 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 All right. So now coming down to the applications, I mean, these are things that we are working on today. I mean, of course, the parts that you see are not the actual parts because we cannot show you those. But these are examples of the things that we have been working on together with several companies now. What I did is I kind of divided those into two broad categories. So the first one is housings and brackets. This is an area of application where PBT traditionally also finds use in the end. And why would you use PBT for such an application? Well, what you see with the PBT is that you get a performance. So the mechanics of the material, the mechanical performance of the material, it, is the same at elevated temperatures. So in this curve over here, where it says DMTA, what you can see is we compared a printed PBT with a molded PA12. This is data generated by us. So you see that a printed PBT part will start sort of dropping in terms of its properties beyond 200 degrees centigrade, whereas a polyamide might go up to 120, 130 or something like that. Now, this is not to say that a polyamide is bad and a PBT is good, or the other way around. It's just that for different applications, you need different materials. That's all that is about. So for such an application, you will need a PBT if you're going to go to manufacturing where you actually want to make the part and then, in this case, put it in a car. So the image that you see here is that of a tail light, a housing for a tail light in a car. So basically, all the lamp and the fittings around around the lamp will actually go into this housing. That's what this is. And then, what does this application need? Now, it needs a material which will be able to sustain its performance at elevated temperatures, so that this component can withstand, short and long-term thermal exposures. Because this car could be in Alaska, but it could also be in Abu Dhabi. So it needs to be able to go from 50 degrees to 50 degrees centigrade to minus whatever degree centigrade that it goes in Alaska. So that's kind of the thing that we are talking about over here. Next to that, as I said, the electrical components of a lamp are actually going to go inside this housing, which means you need certain electrical properties. So you need electrical resistance, you need dielectric strength, which will give you protection against, if there is power breakdown or if there is a leakage of power or something like that, then you need a housing which will make sure that it will be able to protect the components inside as well. And lastly, PBT from a chemistry point of view has less moisture uptake as compared to, say, the PA12 or any polyamide actually. And that is important for these parts also from a safety point of view, because you do not want the housing of a lamp inside your car to change dimension because it was exposed to moisture in the end, because that can become a pretty concerning safety issue actually. So you get sustained dimensional accuracy to ensure safety with this material. That's why you will use PBT for such a product. Sorry, Steve.
So yeah, I mean, don't want something swelling, right? Because all of a sudden the tail light pops out of the back of the car when it's exposed to moisture, especially in a place like Alaska with a lot of humidity and everything else. Now, when you talked about like the electrical resistance, I've heard this acronym thrown around, ESD, electrostatic dissipating. Is that the same thing as this, or is that more of just a property of PBT?
No, so it's ESD is a different property altogether, and that is an added functionality that you need to add to a material. So most plastics do not provide inherent ESD properties. So we will basically have to add certain components to it in the formulation to make sure that they will be ESD safe, if that is the requirement of the application. So electrical
Okay.
resistance is I mean, I have data for it here. So you talk about, this is kind of resistivity. So how much volume resistivity do you have per meter for this material, and then we compare that with with PA12, or you look at a breakdown voltage, which will, again, you see higher values here, but the more important thing is that you don't see big drops suddenly. When it's dry, conditioned is basically when they were exposed to air, so to speak, so exposed to moisture. And again, here you see that, okay, you basically end up with a higher property value for PBT. That's what makes it suitable for these kind of applications.
Really, we actually have a question about PBT in general. Can the weight be changed, and how, like with additives or anything like that?
The weight
material
of the okay, so I'm guessing you mean the density of the material. There could be some tricks that can okay. So yes, I mean, there are some reinforcements measures that we can take to actually make it more lightweight, if that is the concern. Then that is something that we can talk about. So that would be it will be a development or a recipe change from our side, but that should be possible. It can be worked on. The other application I wanted to highlight is power electronics. So, components within a battery pack or module components, or things like this. What you see here is like you see like here, which is kind of a fuse box that has been printed in PBT. I mean, these kind of applications actually are very, very common to PBT in traditional manufacturing. So that you have these very complex connector pieces and those kind of things, which is what you might use the material for. And again, I mean, different applications, different things are important, right? So it's not like so in this case, because it's a pure electrical component in the end, so yes, the electrical properties become important, more important, let's say, than in the housing side of things. So that's what is highlighted here. But in the end, the effect is the same, right? So you need the protection against power breakdown. You need protection against or a dimensionally stable part, because there are things that are going to go inside this, and that's what you want to focus on, and that's why the material will be used for something like this in the end. What is the future of PBT for us, at least? What we see is that there are a few trends which I mentioned already in the beginning. You see connected mobility, you see electrification of the powertrain, which is already happening. I mean, the phone is the car, according to me, is like becoming a giant phone, a giant smartphone of some sort. There are that many electrical components in the car, electronics in the car, and so on. The good news of that is that because all this is new, companies are willing to use newer technologies in these vehicles, right? So increased use of AM in these vehicles, also more customized components. Sometimes you also need components in there which you may not be able to make with standard industry traditional manufacturing techniques, and companies are willing to take that risk because it is new, and they can designers can actually do more different things with it than what they could do with say the regular vehicles and so on. More electronics means also increased demand for high voltage components. We come back to the electrical properties and so on. So in the end, if you have more electronics, you need certain electrical properties, and that's where PBT comes in. That for us is basically the sweet spot for PBT, and we see that there would be more demand for such a material as these trends continue. From a future development perspective, so yes, indeed, adding more functionality to PBT. So Steve mentioned EST, reinforcement of the material, flame retardancy, improved mechanics. So what we talked about in terms of the brittleness of the material, that's something that we are working on. So increased toughness and so on. So those are the things that are in our kitchen, so to speak, right now, that we are trying to work on for this material. So it's not one and done. This is the first version that we come out with, and then moving forward, we want to introduce more functionality to the material.
Now, Nirali, when you say like you're going to go through the developments and everything else, when you talk about the kitchen, you're talking about the lab, right? You're talking about chemists going down to like the actual molecular structure of these chemicals, changing things to get them to be able to have all these new abilities, right? Oh, wow.
Yes. Yeah, these are really developments. Yeah. So it's, and there's a lot of expertise in-house, right? So because from the DSM's side, DSM has and that expertise came with us to Covestro. So there's a lot of expertise in-house in general on these kind of polymers, but also on compounding. So really making functional compounds of these materials, on flame retardancy, and how do you actually give a material a flame retardancy in the end, which will also be environmentally friendly. So there's a lot of expertise that came in, which of course we still continue to work on. But yeah, this is really proper development of materials.
Now, on average, how long does it take to develop a new version of a material or a new modification? I'm not guessing it's like software where it's like version 2.3 every couple months, right? Like this is much longer process, much more stringent testing, that kind of thing.
Yeah, and it is to an extent it starts becoming application specific. So, for example, if a customer comes to us with a specific application and says, "Well, this is what I want my part to do," then that, and we love doing that. We love working with customers to jointly develop a material. So this is the starting point, and then with that we can work together to say, okay. This and this functionality is needed, and then let's work on it. And yeah, in terms of development timelines, it really depends, what kind of development it is, but it could be between 6 months to 1 year or something like that is what we are talking about. And it really depends what kind of application.
We have a question about the testing slide that you showed earlier, comparing PBT to PA12, asking if it's wet or dry conditions that was tested in. Okay, great. And then,
it was a dry
Steve,
conditions.
I'm going to throw this
PHDT.
question to you on the cost of PBT compared to other polymers. And you're on mute, Steve.
I guess the webinar didn't want me to talk anymore. No, this is one of my favorite questions, having been in the additive space for a while. It all depends, so the cost of the raw materials, it's going to depend, but really at the end of the day, it's not really about the cost of the material. And what we're talking about, it's the cost of the part. So that's when you're going to come to Shapeways. It's when you're going to work with us. We're going to be able to help you figure out that price. But that's all going to depend, right? So it's really going to be about more like what you're making and what kind of material we're making. So yeah, raw material, not really the more of the concern here. It's really more of the focus of bring us your part and we'll figure out a price for you.
Are there any color treatments like dyeing for PBT?
Yes. So we, in fact, Shapeways has done some colored parts for us from PBT. So yes, the material can be dyed. That's something that is possible, actually. Yeah. Okay. And then again, just talking about some other things out of the kitchen and so on and so forth. So we just wanted to mention that, okay, we took PBT as an example, but of course, PBT is not the only thing that we work on. We talk right now specifically about the powder bed fusion space. And there we last year released a polypropylene powder, which has a food contact approval for in the EU market. And you can read down below in the slide the entire regulation that it meets. I will not read that because it will take forever. But yeah, that's something that we introduced last year. We are working on a black version for machines which work with near infrared lasers and those kind of things. And then some very exciting materials which we are hoping to launch pretty soon. So soft elastomeric materials. So the TPU families, of course. I mean that's Covestro's domain really. So that's something that we're working on, but also TPE, which kind of comes in from DSM side, materials for medical use, which come with, relevant testing around medical use and so on, materials with high rebound rates for certain applications. And also more biosourced, more biodegradable materials, and so on and so forth as well. So that's what we are doing right now, and we are quite excited about that, to be able to talk more about it eventually in the future. I think that's
that part could be dyed. Do you have a range of colors? I don't know if you want to take this or Steve.
I mean, we've dyed the colors, so we do have a wide range of colors. You can see kind of the colors that we do offer on Shapeways material on our website. But again, I think the biggest thing that you need to do is just reach out to the Shapeways sales representative. So I think that's going to be your best bet, because again, it's also going to come down to what kind of part you're making and how big is it. Also that's really going to come into play when we're trying to figure out what the color you are. Pantone matching is probably going to be really hard with this specific material, but again, we'll do what we can. So please reach out.
And then we have a question about chemical resistance of PBT, especially with ethanol. Nirali, would you like to take that one?
Yeah, sure. So PBT is actually a very chemically resistant material. If you can reach out, I can send you a more detailed data on
that is a great segue. So for those of you that didn't see in the chat, we have included the design specifications and the material detail sheet for PBT, so you can download those. And it looks like Eloise, who is on the Shapeways marketing team, also put in a link to visit Shapeways for more information. So we will definitely answer any of those questions that you have. And great. Oh, how do you get in contact with Shapeways? So if you go to shapeways.com, there is a form that you can connect with sales and an expert on 3D printing, depending on what your question is. And we have an applications team as well as customer support that can help with a whole host of questions. So, and I do see that there is questions about weights, about specific materials. So we will follow up with that question separately, because I think that's more involved than this webinar will cover. But thank you very much, Nirali and Steve, for talking us through PBT and all of the applications. I think this was a great webinar, and I will turn it over to you two to say your goodbyes and all of that to our attendees today.
Sure. I just want to say thank you for being here, Nirali, for your partnership, with this whole recent Covestro merger. I'm just excited to see kind of where this is going to be taken. It sounds like the perfect strategic partnership, and love what you do with Shapeways, and even the future of PBT is exciting, especially with the amount of electric cars that are being introduced to the market, and where just kind of that market is going. So again, thank you for being here. Enjoy the time.
Thank you, Steve, and thank you everybody for joining. Yes, Steve, also the sentiments are the same from our side. I mean, it's been a really fun partnership with Shapeways so far, and we hope to continue to do that. And thank you everybody for listening in. Hopefully this was useful for all of you, and feel free to get in touch so that if you have any more questions, or if we can help you in any way, shape, or form. And thank you, Rhonda, and Eloise for doing all the work in organizing.
Thank you so much. And for all of those that are in attendance, this will be recorded and emailed out to you in case you want to rewatch it or share it with a coworker. And with that, I'm going to say thank you and have a wonderful week. Bye.
Thank you, everyone. Bye-bye.